WAN switching. In this video, we are going to discuss about switching and various switching techniques. Switching. Whenever we have multiple devices, it's better to connect them together to make the communication possible. So this direct communication between multiple devices is possible with the help of switching. A switched network consists of a series of interlinked nodes called switches. Switches are devices capable of creating temporary connections between two or more devices. In a switched network, some of these nodes are connected to the end systems, such as computers or telephones. Others are used only for routing. In this example, you can see A, B, C, D, E, F, J, I, H, G. All these are the end systems. It could be computers or any host or telephone, whatever. And 1, 2, 3, 4, 5, those are the switches. Here these are directly connected to the host, as well as there are connections between the switches too. Switching techniques. There are mainly three switching techniques: circuit switching, packet switching, and message switching. Circuit and packet switching techniques are most commonly used, and the message switching has been phased out in general communications, but it's still used in networking applications. Packet switch networks can be further divided into two categories: virtual circuit networks and datagram networks. This is the taxonomy of switched networks. Circuit switched networks. A circuit switched network consists of a set of switches connected by physical links. That means we can see the circuit switched network in the physical layer. A connection between two stations is a dedicated path made of one or more links. Each connection uses only one dedicated channel on each link. In this figure, you can see, suppose A wants to communicate with M. Both A and M are hosts. In between, you can see switches 1, 2, 4, and 3. It can either take the path 1, 2, 3 or 1, 4, 3 so that A and M can communicate directly. In the figure, when system A needs to connect to M, it sends a setup request that includes the address of system M to switch 1. In circuit switch networks, there are three phases. The actual communication takes place through three phases. They are the connection setup, data transfer, and connection teardown. Just like we see in a TCP protocol, this is connection oriented. So initially there will be a connection establishment between A and M. Switch 1 finds a channel between itself and switch 4 that can be dedicated for this purpose. Switch 1 then sends the request to switch 4, which finds a dedicated channel between itself and switch 3. Switch 3 informs system M of system A's intention. That means switch 3 will communicate with M that A wants to communicate with M. In the next step to make a connection, an acknowledgement from system M needs to be sent in the opposite direction to system A. So the acknowledgement will flow from switch 3 to 4 to 1 and then to A. Only after system A receives this acknowledgement is the connection established. End-to-end addressing is required for creating a connection between the two end systems. So once the connection is established, the data transfer takes place. That is the second phase. Now A can communicate with M by transferring data from A to M as well as back from M to A. And the last phase is the connection termination. Any one of the system A or M can initiate the termination. The data are The data flows continuously from the source to destination, and there could be a periods of silence in between. There is no addressing involved during data transfer. There is end-to-end addressing during the setup phase. So only address has to be mentioned during the setup phase. After the connection is set up, only the data transfers. There is no need to send the address along with all the data. Switching at the physical layer in the traditional telephone network uses the circuit switching approach. Next is message switched networks. Message switching is a network switching technique in which data is routed in its entirety from the source node to the destination node, one hop at a time. During message routing, every intermediate switch in the network stores the whole message. In circuit switching, we can see the data are sent continuously. In message switching, the whole message is sent at once. If the entire network's resources are engaged or the network becomes blocked, the message switched network stores and delays the message until ample resources become available for effective transmission of the message. In message switching, the source and destination nodes are not directly connected. Instead, the intermediary nodes are responsible for transferring the message from one node to the next. In this figure, we can see if A wants to send a message to H, there are so many intermediate nodes. It could be switches or it could be other host. So it has several ways A, B, D, F, G, H or A, B, C, F, G, H or A, B, C, E, G, H. There are several paths for A to reach H. In our case, suppose we want to send a message called message 1. And suppose it is choosing the path A to C, A to B, B to C, C to F, F to G and G to H. So when A is sending a message to H, the whole message will be first forwarded to B, then B will be forwarding the whole message to C, then C will send the message to F, then it to G, then to H. So in the path, if we find any traffic between C and F, this host C will be stored. The node C will be storing the message in its buffer for a time until it seems the path is free. So once it finds the path is free, it will send the message to F. That means because the size of the message is high, all nodes should be having a buffer size of at least the size of the message. Also, it has to wait until there is no traffic, until the path is clear. So that is the greatest disadvantage of this technique. Every intermediary node inside the network needs to store every message prior to retransferring the messages one by one as adequate resources become available. If the resources are not available, the messages are stored indefinitely. This characteristic is known as store and forward. Every message should include a header which typically consists of routing information such as the source and destination, expiry time, priority level, etc. Because message switching implements the store and forward technique, it efficiently uses the network and there is no limit for the messages. Disadvantages of message switched network. Because the messages are fully packaged and saved indefinitely at every intermediate node, the nodes demand substantial storage capacity. Message switched networks are very slow as the processing takes place in each and every node, which may result in poor performance. This technique is not adequate for interactive and real-time processes such as multimedia games and voice communication. Packet switched networks. We have seen there are two types of packet switched networks, datagram networks and virtual circuit networks. Now what is a datagram network? When message passes through a packet switched network, it needs to be divided into packets of fixed or variable size. Here we are not sending the message as whole, we are dividing the message into fixed or variable sized packets. The size of the packet is determined by the network and the governing protocol. In packet switching, there is no resource allocation for a packet. This means that there is no reserved bandwidth on the links and there is no scheduled processing time for each packet. Resources are allocated on demand. The allocation is done on a first come, first served basis. When a switch receives a packet, no matter what is the source or destination, the packet must wait if there are other packets being processed. In this figure, you can see the messages sent from A to X. So the whole message is divided into 4 packets, 1, 2, 3, 4. And in between you can see many routers. See, each packet is taking its own way. There is no rule that each packet should choose the same way. We can see that 1 and 3 are going in direction to the right, and 2 is going down and 4 is going along across. So somehow they are reaching the destination. There is no fixed path. When a node reaches the packet, it will search for the network, it will search the traffic, whichever path is free, it will choose any path. So if there is any problem in one path, it will take another route and it will reach the destination somehow. Only thing is that it is not necessary that all the packets will reach the destination in the correct order as it is sent by the sender. We can see in X that it is reached in the order 1, 4, 3, 2, which is not the same order sent by the sender. So it is the duty of the upper layer protocols to reorder it. But we don't need to wait in the network for long, as well as it doesn't need to store huge amount of data. The datagram networks are sometimes referred to as connectionless networks. We are not having a dedicated path between the sender and the receiver as in the case of circuit switched networks. The term connectionless here means that the switch does not keep any information about the connection state. There is no setup or teardown phase. Each packet is treated the same by a switch regardless of its source or destination. Here each switch has a routing table which is based on the destination address. The routing tables are dynamic and are updated periodically. The destination addresses in the corresponding forward output ports are recorded in the tables. This is different from the table of a circuit switched network in which each entry is created when the setup phase is completed and deleted when the teardown phase is over. The destination address in the header of a packet in a datagram network remains the same during the entire journey of the packet. Switching in the internet is done by using the datagram approach to packet switching at the network layer. Virtual circuit networks. A virtual circuit network is a cross between a circuit switch network and a datagram network. That means there will be a connection establishment phase as in the circuit switch network, as well as the data will be divided into packets as in the datagram network. As in a circuit switch network, there are setup and teardown phases in addition to the data transfer phase. Resources can be located during the setup phase as in a circuit switch network or on demand as in a datagram network. As in a datagram network, data are packetized and each packet carries an address in the header. Here the address is not the destination address but the address of the next switch. As in a circuit switched network, all packets follow the same path established during the connection. We have seen in datagram network, they are not following the same path. But in virtual circuit network, all the packets are following the same path. A virtual circuit network is normally implemented in the data link layer, while a circuit switch network is implemented in the physical layer and a datagram network in the network layer. I hope the switching concept is clear to you. Thank you.